I want to introduce the photoelectric effect. This takes place whenever light comes in, hits some material, and the material, usually an electron, then ejects electrons. There are a number of interesting things that we observe when we study the photoelectric effect carefully, but the sum and total of all of them is that we find that light behaves as if it comes in finite chunks of energy, always the same amount of energy. And if there is enough energy in that light to eject the electron, then the electron is ejected. If the light chunks are too weak, then no photoelectrons are ejected. What I have here is an electroscope which is showing a net charge. That's because this needle here is not straight up and down. And attached to the top here, you see that there's a metal plate, in this case zinc. I'm going to fire some visible light at it, very intense visible light, from this lamp, this flood lamp. And what I see here is that there's no change in the tilt of that needle. Fair enough. Now let's try more energetic particles of light, namely from an ultraviolet lamp. You can't see the ultraviolet here. This is a mercury lamp, so it contains a couple of different lines besides the UV, which is why we can see any light at all. I'm going to aim it carefully at the zinc plate, and I see the needle starts to deflate. Now, the electroscope was originally charged by rubbing this rod against this fur. That means that the original charge on that electroscope was negative. So if firing ultraviolet at a negatively charged plate causes the net charge to go to zero, that means that we are ejecting negatively charged particles, namely electrons.